Okay, so I'm going to imagine that I have two premises, and my first premise is that P implies Q. My second premise is that Q implies R. Now, when I say a premise, it means it's something that we assume to be true or that we know to be true through some other method. Somebody told us that those are true. That's something that we know outside of logic. If those two premises are true, then I want to be able to show that P implies R. So I want to state this in several different ways. First, if these two premises are true, hold on, let me start over here. This part gone. And let me do this. Okay, so this I will say is a premise. And this we will say is a premise. And what do I mean when I say it's a premise? It means I know it's true, or somebody told me it's true, or we assume that it's true. Okay, now I want to know, can I use those two premises to show that P implies R? Let's see. How would I go about doing this? So for step 3, by the way, I put this line right here to separate the premises from the reasoning. So in these steps now I'm going to do some logical reasoning. I'm going to put this vertical line in here, and a vertical line indicates that we're about to start a subproof. So the first thing I'm going to state is that P is true, and that's an assumption. You can assume anything you want. Now, a lot of people have a hard time with this. I'm going to say, if I assume this, what conclusions could I draw? So, if I assume that P is true, for a moment, don't worry about whether P is true or not. But if I assume it's true, then I'm going to state that Q must be true, and that's through implication elimination, using, let's see, line 1 and line 3. And what I mean by that is, if P is true, then P implies Q must be true. So that's how I can conclude that Q is true. Remember, Q is true only if P is true. Well, I shouldn't say that. If we assume P is true, then we can conclude that Q is true. Now let me ask, what else could I conclude? I could also conclude that R must be true. That's also implication elimination, but that's using steps 2 and 4. Again, if Q is true, then Q implies that R must be true. Okay, so what's my next step? My next step is that P must imply R. So what I mean by this, by the way, the name for that logical step is implication introduction, and that's using steps 3 and 5, or 3 through 5, I should say. Okay, so if P is true, then R is true. And up here we're saying, if P is true, let's assume P is true, then R must be true. Now if P is not true, we're making no statement about R. But if P is true, then R is true. That's implication introduction. And so what I've shown here is that these two premises, let me call them sentence phi 1, which I will define as P implies Q, and sentence phi 2, which I will define as Q implies R. I would say that if I define delta to be equal to the set of phi 1 and phi 2, so I would say that delta By the way, let me define psi as equal to P implies R. So I have three logical sentences. I have phi 1, phi 2, and psi. So I would say here that delta, what would we write? We would write that delta entails psi. What this means is, if the set of sentences delta is true, that is to say, if these two premises are true, then the sentence psi must be true. That is to say, this sentence must be true. Another way to show that, another way to say that is that delta proves psi. In other words, if we take delta and assume them to be true, the set of sentences delta, then we can prove that psi must be true. Okay, so I've said a lot, and I just want to wrap up by saying this. The two premises, P implies Q and Q implies R, or psi 1, or phi 1 and phi 2, those two premises, if they are true, then that requires, through our logical system, that psi must be true. Another way to say that is, phi 1 and phi 2, the set phi 1 and phi 2 delta, entails psi.